All right. Well, let's go ahead and look at our homework here. Well, first of all, let's take a look here at the ladybug thing. All right. So wavelength. All right. You've got intersecting E and B fields. So in other words, I've got the E field going like this. If this is my electromagnetic wave, this is the E field. Then perpendicular to that, coming out at us, or going this way, like this, where they're shooting off at 90 degrees to each other, is the B field. Now, what's the relationship between the E field and the B field? Remember, the electric field is equal to, when we're looking at a proton, or when we're looking at the the force of a current or a particle, a proton moving in an electric field, and then the force that felt in the magnetic field, we saw that it was V times B. So this is for like in a regular experiment, but we do it's equal to C, this is page 2, times B. Because the electromagnetic waves, they're moving at the speed of light. All right? So that's the relationship. So let's take a look at one of the homework problems then for this. All right, so here we go. Consider an electromagnetic with a maximum magnetic field strength of 4.5 times 10 to the negative 4. What is the maximum electric field strength in kilovolts per meter? Okay, it's still electric field. Oh, well, we've got that. You just take this, multiply it by C, right? In other words, we've got that down here. There we go. That's how you go about that one. Then 2. All right, so here we go. A particular radio station utilizes frequencies between commercial AM and FM to avoid interference with these common bands. So it picks a frequency of 14.62 megahertz. What is the wavelength channel of this thing? Oh, well, that's not hard either. We've got the equation for that too. We'll write it again. C is equal to lambda times the frequency. You got to be careful because they gave you the frequency. What did they say the frequency was? 14.62 megahertz. What's mega? 10 to the 9th, right? So you're going to get good at your scientific notation if nothing else. So you've got the frequency is 14.6 times 10 to the 9th hertz. And so it's 3.0 times 10 to the 8th meters per second divided by, now look at this, 14.6 times 10 to the 9th seconds to the minus 1. That means these seconds cancel out. Okay? That's hertz. Seconds to the minus 1 is hertz. So we're left with meters, and you just do that division there. And you got to be careful because I think they ask you to come up with it in meters. What is wavelength in meters? Oh, that'll be in meters. That's cool. What else are they talking about? We know how to do that. It's my daughter. Sorry. Your house. Okay, you know how to do field strength and all that. We've already done that. All right. This is kind of an interesting problem. All right, so it says a radar used to detect the presence of aircraft receives a pulse that has reflected off an object 5.5 times 10 to the negative 5 seconds after it was transmitted. Okay. What is the distance from the radar station to the reflecting object. Remember, this is out and back. The radar used to detect the presence of aircraft. Okay, out and back. Now remember, this thing's closing, but it's not going near the speed of light, so we don't have to worry about, that too much. We can treat it like a stationary thing. So, shot it out, went out and back. So the total time is that. So how far out is it? In other words, how do we do this? How do we set up this kind of problem? And then we'll stop this one. So in this one, what'd they say? We'll try this again. I know this is probably might be driving you nuts. We know that C, we know what C is, okay? And we've got an object, so we know that the distance of an object is equal to C times T. Whoop, you probably want to see what the heck I'm doing. The distance of the object is equal to C times T when we're using radar. All right? Well, we know what C is, and we know what T is. Be careful with T. T is equal to 1/2 of T prime, which was given to you, of T given. All right? Because the object is out here. We send this wave, boom, and then it comes back. And the time it took was, in this case, 5.5 times 10 to the -4 seconds, or something like that, -5 seconds. All right? So you got to take half that time for that to work. Okay, good.